Okay.
I'm forgetting that I only got a small part that was wrong. I can just do it.
You can do most of the things.
I just don't trust
Are you talking about on 14?
Yeah.
It's actually a pretty large part because you have to check like a whole bunch of chunks.
I know, but I got like the main problem
Yeah,
right.
there you go. Are you trying to sell your mom joke right now? No. Leave those to the expert. No, not Your video is now live on YouTube. All right. What was that? Adobe. I need to turn that off. I don't even have Adobe anymore. We're not supporting that. Till 3. Done. Y'all are going to whine about it being cold, but it's not going to be cold. It's just going to be moving air. It's going to be okay. All right. So, the 3, we only have to multiply x plus 2 on it. Hopefully next time showing up on time. Minus 9, because we're multiplying nothing on it. And 6, we're multiplying it times x minus 4, right? Easy money. Now, we're going to distribute the 3. And we're going to distribute the 6. 3 times x is 3x. Plus 6, because 3 times 2 is 6. Minus 9 is less than, or maybe let's switch it to equals, because we're going to have to test everything anyway. 6x minus 24. 24, that 4 looks like an x, but it's a 4. Then we combine like terms. And we may as well subtract 6x from both sides. Negative 3x minus 3 equals negative 24. Add 3 to both sides. We get negative 3x equals negative 21. Divide by 3, negative 3. And we get x equals, why is there not, isn't this the one where we like have to, oh no, just kidding. Just kidding. Oh yeah, yes. Positive 7. No, it's not, but we're going to have to check a bunch of things anyway, so we may as well write equals, right? Because what do we have to do next? Yeah, so we've got to set the common denominator equal to 0, right? To find our other critical points, right? So our other critical points are at 4 and negative 2, right? And then, so we've got, essentially, you don't have to do the number line, but we essentially have this number line to work with, right? Now what do we have to do? Yeah, we gotta check here, 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 and here. So what are we going to check over here? 0 is not over here. 0 is in here.
Negative 0.
Negative 3 is fine. So 3 over negative 7 minus 9 over, what do we do, negative 3? So negative 7 times negative 1.
Negative 7? Oh, yeah. Oh, yeah.
Is that less than 6 over negative 1? So negative, because we don't know, and that's what we're trying to figure out. Yeah, so negative 3/7 minus 9/7, is that less than negative 6? I did, you're right. So is negative 12/7 less than negative 6?
No.
That'd be negative 1 and something, right? Is negative 1 point something less than negative 6? No, it's not. Doesn't work over here. So now we've got to check over here.
0.
0 sounds great.
Thank you.
3 over negative 4 minus 9 over negative 4 times negative 2 is negative 8. Is that less than 6 over 2? So it's negative 6/8 plus 9/8. Is that less than 3? So is 3/8 less than 3? Yes, it works over here. So now we need to check over here. I will save us the time and trouble because we're trying to get to as many questions as we can do. It doesn't work here, and it does work here. So then, how do we write our answer?
X is, there's no solution? Is there no solution?
Doesn't include.
Yeah, that's right.
Actually, it can include 7, right? Because 7 wasn't one of our doesn't work here critical points. 7 was a thing.
That original thing is not.
Right. It doesn't. Yeah, that's right. That's why it's this instead of just x. Because if it wasn't this, it would be x equals 7. Circle it and move on with our life. But because it's this, we've got to check all these other things. And now it's anything in these ranges. Anything between negative 2 and 4 works. And anything from 7 to infinity works.
So it doesn't have to be a less than or equal to.
Oh, you're right. That's what you were talking about. Not the fact that the less that, but yeah, you're right. Yeah, because it wouldn't be equal to because of, yes. Yeah, because there's no line here. You are correct.
Both of those or just that?
That is all one thing. Yeah. What does that U looking thing mean?
Means it doesn't include.
Means union. Means so the doesn't include is because of parentheses, not square brackets, which is probably what you thought I was asking. But yeah, this U, not the sideways U looking thing. That one means union. So it means this and this. If it's an upside down one of these, that's intersection. So it's this and that, right?
Like that.
It's like where they cross. So like if we've got a line going this way and a line going this way, right? Then it's whatever is intersecting between them two. Whenever we're writing a range, we're almost never using intersection, but that's what the other way around means. Just for a FYI remembery. All right, what other test questions do we have?
8 or 12.
8 or 12 or 1?
Yeah, 1, 2.
Let's do 1. Start there. Had a lot of mistakes, both weird and otherwise, on number 1. So that's probably goot. During my geometry class, I had a random person start watching and say, "Teacher, how to read biology?" I told them that I don't teach biology, so, you know. Well, I don't know for sure whether they meant read or meant teach. I don't know. Who the heck knows? X, 6x squared minus 2x minus 2 all over 2x squared minus 5x minus 3 times 3x squared plus 13x plus 12 over 3x squared minus 7x plus 4. So, we made a big deal all lesson about how When you see something that can be factored, you should probably factor it. And still somehow we had lots of people just like looking at these things and not starting there. So where should we start? How about factor? Sounds great. And yeah, on that top left one, we can factor out a 2 to start. It's got a GCF, right? So we can factor out a 2, and we're left with 3x squared minus 2x, minus x minus 1. And then we can try and see if that factors. It doesn't because I made a mistake, and it doesn't factor. It doesn't factor. It cannot factor. Try it. Try it yourself. Try it 12 different ways. You can only try it. In fact, you can only try it 2 different ways. None of them work. 3x and x, 1 and 1 are the only options. There's no way we can get a negative 1. Because neither 3 plus 1 or 3 minus 1 or any of those things, it don't factor. He don't factor at all. He probably should have, but I made a mistake somewhere when I was making it, and he don't factor. So he just sits there. The nice thing about him is he is easy to check because there's only one option. It doesn't work. So that's great. It means the answer is going to be a little ugly, but you know, it'll be fine. Okay, so that don't work, but I bet some of the other ones do. Let's see what happens. Let's factor that guy. 2 sets of parentheses.
I missed when all I had to do in a test was factor one problem, like just the problem. That was the only thing that had to be done in the question.
Nice. Nice. You didn't miss, you miss having problems like that. I follow you, yeah. Yeah, no, gone are the days. Okay, so what are we going to factor now? What are 2x and x. 2 and 1. Is it a 3? Let's see. It is a 3. He just kind of fell asleep halfway through. 3 and 1. 3 and then 2. And can we make that a negative 5? Yes. What do the signs need to be? Negative and negative. This is negative in this one. But it won't work. Oh no. Why won't it work? Because a negative 3 times negative 1 is a positive 3. He don't work. Let's try again. What can we do instead? 1 and 3. 1 times 1 is 1. 2 times 3 is 6. Can we do that? Yes, that still works. And now our signs work at the end. Great. Some of y'all are making grumbly faces like, oh my gosh, I knew that. Why did I make that mistake? It's okay. It's okay. I also made other ones. Okay. How about 3x and x? And then what? 4 and 3, 3 and 4, 6 and 2, 2 and 6, or 1 and 12, 12 and 1? 4 and 3, we say. So we've got a 4 and a 9. Can we get positive 13 out of that? Yes. Plus and plus? He works. Great. Factor this guy. 3x and x. 2 and 2, 4 and 1, or 1 and 4? What are we doing? 4 and what? 4 and 1, he says. Let's see. 4 times 1 is 4. 3 times 1 is 3. Can we get a negative 7? Yes. Minus, minus, he works, because negative times a negative is a positive. It's great. Now what do we start? Now what do we do? Now we start murdering stuff. Let's murder stuff. What can we murder?
3x minus plus 2.
I thought something canceled, but maybe not. Let me look.
Nothing cancels, we all cross.
3x minus 4. Oh, it's because we did it. It's because one of them's. It's because I copied something down wrong or something.
You told us that.
I told you that the 13 was plus because I made it a plus, but it shouldn't have been a plus. It should have been the way it was written as a minus. That's why, because then it'll factor, right? Look at that. Look at me being so silly. But the nice thing about that is y'all, what you coulda, woulda, shoulda done, based on my double mistake, is you could have just rewritten it and circled it and then moved on with your life. It would have been annoying and it would have been silly and you'd be like, this can't be right, but do it. Here's the deal, boys and gals. Do it anyway. Don't just be like, don't do it. Don't go to a test in college and be like, they can't actually all be C. Just mark them all C. The professor was probably a sadistic moron and just mark them all C. It's okay. Don't go to a test and be like, it can't be, and then like leave in disgust. Just do it. Put it down. Great. So now we murder stuff. Great. This one's murdered with this one, and this one's murdered with this one. According to my thing, there's an X minus 1 that goes away. Oh, no, just kidding. LOL, JK. And then we write down what wasn't murdered. How's that sound? Grand?
Glorious.
Wow. That was like, all right. God is good all the time. All the time, God is good. We have made our own math version of that. Grand and then that's fun. I love that. We have our own things. This is now officially a cult. Oh, that's funny. What are your other ones? Soccer and Church of Christ? Oh, that's funny. It is impossible for Church of Christ to be a cult because every Church of Christ congregation is like so different. Like so different. Like Southern Baptists, you pretty much know what you're going to get. But you walk into a church, you never know what you're going to get. if it says Church of Christ, who knows? All right, no, you can't say 12 because 8 is next. Okay. Number 8, we are expected to graph f of x equals x squared minus x minus 6 over x plus 1. By the way, number 9 is a straight line with a hole in it. That's what number 9 is. Number 9 ends up being a straight line with a hole in it.
Yeah.
All right.
Plotted a bunch of points and then tried to connect them, but it didn't make it long.
Then you made some other probably negatives. Okay. What do we need to figure out? Yeah, great. So, vertical asymptotes. Where is it going to be? The thing here is here, boys and gals, boys and ladies. I'm not sure we studied for the right test.
-1.
It is at x equals -1. How did you find that? Because you said the denominator equals to 0. Great.
I thought that couldn't be it. That's too easy.
Oh my gosh. Like I said, don't be like, oh, it's just too easy or this is whatever. Just do it. Mark them all C if they're all C. It probably wasn't, you probably were wrong, but do it anyway.
I even wrote it down and erased it. I was like, no, that doesn't make sense.
Now what?
And then you find the
Horizontal asymptotes.
Does it have a horizontal asymptote?
No.
No. How do I know it doesn't?
X, the degree of the top.
The degree of the numerator is bigger than the degree of the denominator. Now, there is a third type of asymptote. How do I know whether it has a oblique asymptote?
It's like if there's one more.
If it's that, what is true about that makes it an oblique asymptote? It's one more than the denominator, so it has a slant asymptote. So how do I find the equation of the slant asymptote?
Long division.
I divide the top one by the bottom one. You could actually do this one with synthetic division if you wanted to on this particular one, but whatevs. Okay, so to find the oblique asymptote.
I forgot synthetic division.
Is that it's OB? Yes, got it.
Way to go, way to go, way to go. Okay. right. So x plus 1 divided into x squared minus x minus 6.
It's so sad how many things we have to combine now just to do our problem.
I did something wrong because it shouldn't have it. I don't think it actually has a. Oh no, it does. I didn't do anything wrong. Y'all are dumb. Quit lying to me. Okay, that's fine. Do long division because y'all don't remember what I'm even doing anyway. You'll want to remember if you take pre-cal next year because you're gonna do it again, just like we did this year where you do it a whole bunch of times. Okay, great. What do I do?
Find how many times x get x squared.
It goes in x times. Great. X times x is x squared. That's probably a 2. X times 1 is x. Subtract. That cancels. Negative 2x. How many times does x go into negative 2?
2.
No.
-2.
Negative 2 times. Negative 2 times x is negative 2x. Excuse me. Negative 2 times 1 is negative 2. We subtract. That's funny. There's a mistake in the key, but it doesn't even affect anything. Great. This cancels. This is a negative 4. I did do it right. Synthetic division was 100% right. Should have just done synthetic division on the key, and then I wouldn't have made a silly mistake. Great. Doesn't really matter. So, what is the equation of our horizontal asymptote? Y equals x minus 2. Great. Wow.
Or does it matter?
Nope, doesn't matter that it's got an asymptote. An asymptote. That word for that isn't a remainder.
The asymptote on that doesn't matter.
You say remainder?
Swiper, no swiping. Okay. We do get a graph. Sounds grand. And then you plot points. You can probably do 4 if you want to just pick the right ones and then move on with y'all. Where did I set my...
Look how many I did.
Some of y'all probably were... I saw several of y'all that had points that were like, this is on there. If you just would have just realized that there's the asymptotes where they are, you probably could have graphed the thing. And it wouldn't have been a problem. Especially on the right-hand side of this picture. It's like several of y'all, okay, these points are completely accurate. You just forgot how to connect them. So we put an asymptote right here. And then we put an asymptote right here.
Oh my gosh. That looks like the graph I made.
And then you do a few points and discover that it looks like this.
I did that one wrong, but I did that one right.
Ta-da. All you had, the most points you would need is enough to learn that it's here and here instead of here and here or something.
I failed. I don't know what happened.
Because it could have been like this and like this. So you just needed enough points to figure out which of the 4 skewed quadrants they live in. Number 12. What time is it? Sure, number 12. And then we're going to move on with our lives. It isn't.
I missed 20 points.
Number 12 is easy. Do we actually need to do number 12? Do we actually, or could you look at and figure out what your mistake it is? You need a common denominator.
Okay.
What would the common denominator be? 6 times x minus 1.
So
I did that, but then I still failed.
I don't know.
So look yourself and see if you can find your mistake. Start there. You'll get more out of it. And if you can't find it, then whatever else. Yeah, sure. We can do 3 instead. Maybe.
I messed up my common
3. 3 is also easy, but sure, why not? Oh, you know what mistake most of you that made a mistake on number 3 was? The denominator of the left-hand side one, you can factor out a 2. And then you have x plus 7 in both denominators.
Yeah.
I did that actually.
Oh yeah, and you still made some sort of mistake?
Yep.
Did you find it? Not yet? Okay, well let's at least do part of it. And then we'll move on with our lives. Nobody came and bought scrunchies from me.
I did.
Nobody got bonus points.
You said it was a Connect church. So
I did.
I forgot.
I was getting sauteed in the sun.
You were getting sauteed in this. Not from 9 to 4 you weren't.
You know anything? I was playing
From 10 to 4 I was.
That's probably, I could believe that.
I was playing golf from 11.
Golf.
It's 4x, not
I like basically playing golf, except the club was my leg and the ball was
Wait, what day was that? What day was that, Sean?
Saturday.
Yeah, I was working
At the car wash. So, what should we do?
Factor.
We should factor. This one factors into 2 times x plus 7. This one factors into x and 7 and 1 and minus and plus. Isn't it cute? What's our common denominator?
Yes.
All that, right? Great.
Times.
2 times x plus 7 times x minus 1. On the first one, we're only going to multiply it times x minus 1. No, lies. There's something we can do first. Time out. Time. There's something we can do first to make our lives easier. What is it? We can go. Ooh, ah. And then our common denominator is this.
X plus upside down 4, x minus 4.
It is kind of an upside down 4, yeah, sure, great. So then we have 2x times x minus 1 plus x plus 2 times times nothing, over x plus 7 times x minus 1. And then we distribute that and keep on going and move on with our lives, right?
Simple enough. And you have to make sure never
Simple.
to ever close the parentheses. What is that number?
Never to ever.
X plus
You tell me, what would it be?
7.
Yeah.
X plus greater.
Imagine that 7 would be the same as that 7. It's crazy. Let's learn about conics.
Comics or comics?
Is it Harry Connick Jr.? I think it is. Or is it Henry Connick Jr.?
Graphic
What is
marks.
it called?
No, I think it's Henry Connick Jr. No, Harry Connick Jr. But that's not what we're learning about. We're not learning about any crooners. We're not going to learn about Frank Sinatra or Bing Crosby or Harry Connick Jr. We are going to learn about conic sections. Because, Nathan, this is a math class, not a history of 20th century music class.
I like graphic marks.
What page are we
Oh yeah, this lesson. You're going to love this lesson. What is today, Tuesday? That means that this is the only lesson we do today. So y'all are going to have a nice, easy thing. Y'all are going to be happy because everything in this lesson, not unit, but this lesson
It's hunky dory.
is review.
Yeah. Oh my god. I never thought I would see
We're on
today.
the unit 9, right?
Are we doing graphic?
We are on Unit 9. We are doing graphing, but not
I have to put pages in.
on this one lesson.
What should I write?
Everything. The title is Midpoint and Distance Formulas.
Oh wait, I like these.
Okay. Midpoint formula looks like this. The midpoint formula looks like the average of the x's, average of the y's, 2 years ago actually, but also last year.
I learned a question. So I did y'all.
Midpoint formula is average of the x's, average of the y's. It is a point, hence the name midpoint.
Is it x to the 2?
No, it's not x to the 2, it's x2. x1 plus x2 divided by 2, because that's how you find the average of two numbers, yes? Add them up and divide by 2. Average of the y's. And I would argue heavily that it is, if for some reason you don't have the midpoint formula memorized already from 5,000 years ago, the easiest way to memorize it is that. The average of the x's, average of the y's. Because you know how to find average in your sleep. But if you want to memorize it in a formula form, go for it. Let's do distance formula. And then we'll maybe do an example, and then we'll let you leave early. Or maybe take a question or two more from the test. We'll see what happens. Okay, distance formula. This is another one that y'all probably know. Actually, you know what we're going to do?
What?
Because we have plenty of time, I love that. We are going to do something that is often done in math class, but I don't usually have enough time. Definitely not in Algebra 1. When we first introduced distance formula, we are going to derive the distance formula. Let's do it.
Is that a good thing?
It's a great thing. So if I have point A and I have point B, and I want to find the distance between them.
I'm pretty sure I learned this a long time ago.
You definitely did. So if I want to find the distance between them, I could do it this way. So I am looking for this one, right? This one could be little b, and this one could be little a. And now, what could I do to solve for c?
Pythagorean theorem.
Pythagorean theorem. I could do a squared plus b squared equals c squared. So, what do I do to solve this for c? No. I want to solve this right here for c. There ain't no numbers on there. How do I get rid of this? Square root both sides. Thank you. We unsquare it.
Yeah, I love the bricks over there. Love the bricks over there.
Actually, all I know for sure is in Belgium they do it that way. I don't know for sure about Britain, other than that one. She didn't even hear the joke. Oh, good, good. She just didn't like it. Okay. All right, so this is the distance formula. Now, here's the deal. Are we ready? Are we paying close attention?
No.
If A is x1, y1, and B is x2, y2, because they're points, right? Points in space. Then A, if this was like correct and like up and down, to find A, I would take x2 and subtract x1, and that would give me this linear distance, right? And B, to find the B distance, I would take the y2 and subtract the y1, right? So the distance formula is, as you probably already know, if you don't, here it is again for you. D for distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Because Pythagorean theorem. Let's do an example. And then we'll assign you some homework. How does that sound? Grand and glorious?
Okay. This is going to be so difficult.
No, it's not. That's false.
We can't do Algebra 1 anymore.
TBH, nothing in this unit is all that hard. Just everything after this unit is kind of new.
Does new mean hard?
What?
Does new mean hard though?
No. But it's not completely new. It's related to stuff we've seen before. We are going to have to complete the square again.
Does it involve graphing?
Yes.
We've done some of it before.
Okay. All right. Find the distance and the midpoint between, somebody tell me a number.
1.
7, -1, and
300.
43, 7.
somebody give me another number.
300.
8 and 42.
-8,
9.
4. I don't know why y'all are giving stupid numbers. All right, so to find the midpoint between those 2 points, what would we do? Average of the x's, right? So 7 plus -8 divided by 2. Average of the y's, so -1 plus 4 divided by 2. What is 7 plus -8? -1, so -1/2. -1 plus 4 is 3, 1.5. Isn't that cute? Find the distance between those. We shove it in the distance formula, which is d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So everywhere there's a variable, we put a parenthesis. Yes. And then we start shoving numbers in it. What are we going to put right here? -8. And what are we going to put right here? 7. You don't have to sound so depressed about it. Calm down. What are we going to put right here? 4. Right here we put a -1. We ka-chink, ka-chink. What is -8 minus 7?
-8 minus 7 is
-15, quantity squared. Plus 4 plus 1 is 5. What's -15 squared? 225. I was really hoping someone would say negative, and then I would get to give you a hard time about being in Algebra 2 and not knowing how negatives work. Okay, 5 times 5 is 25, so plus 25, so the square root of 250. We reduce that square root. What is there a perfect square that goes in it? $25 obviously goes in it, right? Right? Square root of 25 times the square root of 10 equals 5 times the square root of 10. There it is. We did it.
We have it exact.
Units. That says units. He's probably drunk, but that's what he says. Homework. Y'all think y'all can handle this lesson?
No.
Now, I'm going to throw out there, just this, y'all didn't listen to me last lesson, many of you. Don't neglect to study the easy lesson, because it will ooze out of your ears if you don't. Learn, so those of you who are like, yeah, I'm feeling that pain right now, don't let your mistake, don't not learn from your mistake. Don't do it twice or thrice or a bunch of times. Page 596. Numbers 10 through 38 evens. We're going to start on the next lesson. Why not? Parable. Yeah, I lied apparently.
Art said we could go over questions.
I said that's probably what we're going to do, and I changed my mind. I'm allowed to do that because I'm a strong, independent woman. It probably isn't, but it was a good joke. Y'all laughed. Okay, great. We're going to do 9-2, parabolas. We know about a parabola. We know some things about them. We absolutely do. However, we're going to shine a brand new light on them because parabolas are going to be our first conic section. So let's talk about what it means to be a conic section. We're going to draw a picture. It's going to look like this. That's not a circle. That is an oval. Definitely not close enough because perspective. Is that a duck? Yes. OMG. Why is there a duck here again?
She couldn't even outside.
Is that your emotional support duck?
Yes.
I
Those
bring
two
my
go
emotional
outside and
support
they'll like-
German Shepherd Rottweiler next time.
Which will eat the duck.
Or be afraid of
I may have told some of these people in this room this story before, but supposedly my mom owned guinea pigs. And she was before I was alive, so I can't confirm it. But supposedly she owned guinea pigs, and one day there was a stray German Shepherd that walked in their front door and came and ate her guinea pigs. Which is wild. So what the rest of this unit is all about is how if I take a plane and I chop this, what kind of shapes do I make? So if I chop this like this, then I end up with a parabola, which I'm going to attempt to kind of draw. If I take a plane and I chop it there, I get a parabola. If I chop it up and down, actually this one, well, I drew it, I'm going to get an ellipse probably. But if I do it at an angle enough, I'm going to get a parabola, right? If I do it this way, I'm going to get a circle. If I do it a little bit this way, I'm going to get an oval. If I do it this way, I'm going to get a hyperbola, which is two parabolas going back and forth. We're going to learn about all of those and their formulas. Making sense? So we are beyond only function parabolas. All the parabolas that we've learned about, what are we crying about?
I have no idea what you're talking about.
All of the parabolas we have graphed thus far have been up and down. But now we're going to graph parabolas either up and down or left and right.
So why is it shaped like that?
It's two cones that are spun. It's where this comes from, and there's all kinds of engineering and all kinds of stuff that goes into conic sections being useful in real life. But what it is it's a circle. It's a straight line that has been revolved around an axis. That's where that shape comes. That's how you would construct it mathematically. If we take a circle and we spin it around the x-axis, you get that shape. And then we chop that shape, we get conics. The first one we're going to talk about is a parabola. Great. Let's draw another picture.
I like drawing pictures.
Well, good. That's going to be the entire rest of this unit. I've said that like so many times, and now is the first time we're saying, oh, actually, that's not true. I'm pretty sure Landon said, oh, no, the first time I ever said it. But, you know.
But now we understand what you mean by picture.
I like this though. This seems fun.
This does seem more interesting than just numbers. It has pictures.
Is that not exactly what this is?
Exactly.
Okay.
Um,
We're going to talk about some vocabulary.
I thought this wasn't an English class.
What kind of stupid sentence is that?
I'm 98% sure you've said that before.
Well, if you've made the same stupid joke before, then I probably have had the same stupid response to it before. So yeah, that's how that typically works. That is something like a parabola. So we've seen that before, right?
Yes.
So there are a few new words that we need to add to our understanding of a parabola. And actually, I should probably draw that. Yeah, they did this. That's probably wise. Actually, it'd be easier to see what's happening. I'm going to redraw my parabola. If you're taking math notes and pen, I'm sorry, except I'm not sorry because you probably shouldn't do that, especially in my class. Y'all should know better by now.
You yelled at me for a long time for doing that, so I'll stop.
I mean, it's whatever. You want to do that, it's fine. You're just going to regret your life choices like often, right? Okay. We already know about one point on this parabola, right? What is the one point that we already know a name for?
The vertex.
The vertex. That's easy. No, not the vortex. That's a different thing.
I mispronounced it for a long time as the problem. I think it's funny.
Nice. The vertex. There is a couple of new points, and well, there's a new point and a new couple of lines we're going to talk about. One of them you could probably figure out. There is another point, which on this parabola would probably be about right here-ish. And it is called the focus. I will explain what it means in a second and where it would be useful in real life, at least one example of.
Glasses?
No. That is a word connection.
Camera?
Oh my gosh, guys. There is a line that's down here that has a name.
Bingo.
And it is related. It is related to the focus. This line is called the directrix. Like it sounds. Direct. Rix. Directrix. So how they're related, there's one more line, but I'm going to talk about these like where these, like what these are for. So if I was trying to construct a parabola, or more likely a paraboloid, because 3 dimensions. In real life, what is a paraboloid? Anybody know?
Three-dimensional parabola?
It's a parabola that if we took it and we spun it around its axis of symmetry, that's the other line, we would have this shape-ish. We would have a satellite dish, right? The focus, what the focus is kind of got two things, but it's also, we're going to relate it back to the directrix. The focus is if I'm taking and sending satellite images into the paraboloid, they're going to bounce off of there and hit the focus every single time, no matter where we're coming from. So that's how it would be useful. That's how satellite dishes work. If you've ever seen a satellite dish, it's got that little arm that comes out the middle. That's sitting right at the focus of that paraboloid. So that because if it wasn't shaped like a paraboloid, then that satellite would have to be lined up perfectly in a straight line with your house, and that ain't going to fly, right? So it's got a paraboloid so that we can have a range, and the bigger the satellite dish, the bigger the range of what you can hit, and the more reliable it's going to be. Now, the way the directrix relates to the focus is if I was constructing this parabola, then what I would do is I would take the directrix and I would bend it around the focus and I would have the parabola. So that's how it's related. Now there's one more line that exists on here that is named. I've already said it. The axis of symmetry.
Down the middle.
Which is another one that you already know about, right? You know about the axis of symmetry on a parabola. Which is exactly what it sounds like it is, right? Did I do it, Mom? Yes, I did. Look at that. Who'd have thunk it? That's the line that goes straight through the focus and is parallel to the directrix. Oh yeah, I forgot when in this book they add that. Just kidding. There's one more thing, but it's not a line segment. You ready? You paying close attention? Because it's a useful way to graph the thing. So there's one more thing that we're going to label. I'm going to get rid of my satellite rays so that it's less confusing.
Mine's already past that point, so.
Is it? Do you have more than what's on there? Because how is it past confusing? I added an extra thing because I felt like it. There is another thing that is useful to know, and that is this line segment right here.
I remember when I was just learning what an x and y axis is.
That's funny.
The evil chuckles. Ruin your dreams.
This line segment has a name, and it also, and it also has a formula, which is handy because then we can use it. We're ultimately going to be able to graph these things with less points, right? All of these, circles and ovals and parabolas and hyperbolas, all of them, we're going to be able to get just a handful of points and then connect the dots and then we're done. And we're not even going to have to do a whole bunch of substituting and all that kind of stuff, right? So this has a name and its name is the lactus rectum.
When I first read
That sounds like a biology name.
Well, there's a reason for that because lactus rectum would be in Latin and many biology names are also in...
There's no C right there.
Oh yeah, just kidding. Lattice, that makes more sense because lateral. It also sounds, well, it sounds like rectum because it is rectum.
Yeah, I know.
Okay, great. It is the distance, if we draw a line segment parallel to the directrix, perpendicular to the axis of symmetry, then it's the distance to go through the focus to get to the edges of the parabola. So if we have this point and these points, we connect them and we have a parabola. Yay. Right? Great. How we doing? Pretty good. Let's get some formulas on there and then you can leave. Because my goal right now is to get even further than we did last year.
How far did you get left?
Last year we got through part of Unit 9. My goal is to get through all of Unit 9. We'll see what happens. I'm not stressed if we don't, but that is my goal.
What happens if we get to Unit 10?
We probably won't. I don't even remember what Unit 10 is. What is Unit 10? Let's find out. Series? Yep, that's what I thought. That would be cool because that's kind of hard. You have to think. So that would be fun. That would be fun. Okay, I don't think that's going to happen. All right, so now, like I said, we can have parabolas that open up or down, but we can also have them opening left or right. So there are two different standard forms for a parabola. There is a vertical one. And the standard form there looks like y equals a times x minus h quantity squared plus k. We've seen this. This is what we've already seen lots. Yes? We even know what all those things are. All we're going to add to this is how to get to some of those other points that we had. So if you have a horizontal one, you could probably guess what it looks like. But in case you can't, it looks like x equals a times y minus k quantity squared plus h. So this one opens up or down, right? So this way or this way. This one opens left or right. This way or this way. When I was teaching this recently in pre-cal, I made like 5,000 mistakes writing these formulas, so hold on to your butts.
Not read the formula in my.
I don't, serious, I made so many mistakes it wasn't even funny, so. But because of that, I probably am going to explain it to you better than I did to them, so yay, great. All right, so the vertex. Yes, ma'am.
Are you still teaching? My mom asked me to bring her car.
Yeah. What?
My mom asked me to bring her.
Okay, good. You can do that. Vertex. This is as far as we're going to get on both of these. Defined the vertex. How do we do that? Y'all already know. You probably already know. You ought to already know.
I learned this so hard because I forgot to do it.
It's HK, y'all. HK on both of them. Oops. Now, you're going to notice that on all of these formulas for the parabola, for the ellipse, for the circle, the hyperbola, H always goes with X and K always goes with Y. Yeah? So that's how we keep those straight. And that's as far as we're going to get on that today. We'll finish that up on Thursday. and probably talk about ellipses. I think that's what comes next. Is that what comes next? Let's find out, shall we? Yes, no, just kidding. LOL. What comes next? Are we doing circles first? That would be silly. Yeah, circles. Great. Circles you will like, actually, because circles are easy, but you're probably going to have to also complete the square. So,
I don't like those, but I like circles.
circles are easy to graph and easy to figure out and all the things. Yes, ma'am? Okay. I'm going to stop this video before I forget, and then I will pick up your test corrections.
Hey, Sean, numbers are fun.
Numbers are so fun.
Yes.
Sheldon, hold on, don't stop it yet, don't stop it. Whoa, whoa,
It's blurry.
whoa,